Hello students, now we shall discuss today grouping of cells. There are three types of grouping: series grouping, parallel grouping and mixed grouping. First of all, we shall discuss the series grouping. Grouping of cells. There are three types of grouping. Number one, series grouping. Number two, parallel. And number three, mixed. So first of all, we shall discuss series grouping. It is taken in two parts. One, when all the cells are identical, the EMF and the internal resistance of the cells are equal. And the second one, the EMF and the internal resistance are different for the different cells. So case first, all the cells are identical. Let n cells, let this is C1, this is C2, this is Cnth cell, and connected to an external resistance R. The internal resistance of each cell is R, and EMF is E. Let there are n cells connected in series. EMF of each cell is E, and internal resistance of each cell is R. The negative terminal is connected to the positive terminal of the next cell. In this combination, the negative terminal is connected to the positive terminal of next cell. Then to an external resistance R. resistor R as shown in figure. The effective EMF equals plus up to n times. It means NE. E effective equal to NE. Similarly, the internal resistance, the effective internal resistance. Resistance is R effective R plus R n times. It means NR. The net resistance of the circuit is R dash is equal to R plus NR. So the current of the circuit is I is equal to effective EMF and net resistance. Or NE upon R plus NR. This is equal to current of the circuit when all the cells are connected in series to an external resistance R through which the current is to be passed or the energy to be utilized. Conditions. Case first, if R is greater than NR, in that case NR is neglected and I equal to NE upon R. It means N into E upon R. E upon R is the current of due to the one cell. So net current is added. The current of the circuit is n times due to one cell. So it is better to connect the circuit in series when the internal resistance is less than the external resistance. Case second, if NR is greater than R, then I equal to NE upon NR or E upon R. The current just equal to UT1 cell. The current is equal to one cell. So it is better to connect the cells in series when the external resistance is more than the effective internal resistance of the cells. So this is the expression when all the cells are identical, but the cells are different. EMF differ and the internal resistance of the circuit also differ. Circuit of the cells differ. Then noted it. Now, case second, the cells are different of EMF and different internal resistance. यहाँ पे E ले लीजिएगा. Then let two cells E1 R1, E2 R2. Consider two cells. One having EMF E1, two cells having EMF E1 and E2 and internal resistance R1 and R2 respectively. Then suppose there are 3 points X, Y and Z. The potential difference between these two BXY, potential difference between these two YZ, and if we take the effective, R effective and E effective, then potential difference between these two BXZ, the potential difference across this cell E1 R1, E2 R2, respectively. The potential difference between the points X and Y, Bxy is equal to E1 minus I R, and potential difference between Y and Z, then B by Z equals E2 minus I R2. Current is the same through the circuit. So current I and current I is the same, but EMF of this cell is E1 and interresistance R1, and EMF of this cell E2 and interresistance R2. Now potential difference between X and Y, Z, X and Z. Then potential difference between X and Z. So Bxz equals Bxy plus B by Z. The potential of this cell and potential of this cell is added. Then final E1 minus IR1 plus E2 minus IR2. This becomes Bxz equal to E1 plus E2 plus I R1 plus R2. So the effective EMF is E1 plus E2 and effective resistance is R1 plus R2. So the effective EMF or E effective is equal to E1 plus E2 or R effective is equal to R1 plus R2. This is all about due to individual circuits of the cells. And now we shall discuss next one, that our series combination of the cells complete here. Now we finish. Okay.